renowned astronomer Brian Cox, who wonders if we are witnessing a supernova explosion that could change the night sky forever, raises serious concerns. In the vast cosmic structure where stars are born, grow, and die in dazzling ways, scientists and the general public are concerned about just one star. Betelgeuse is a prominent red supergiant in the constellation of Orion. It has long been a mystery because of its unusual red color, its variable brightness, and its enormous size and age. Recently, curiosity has grown as this celestial giant approaches a potentially historic stage in its life cycle. So what does this change in Betelgeuse mean? Is this the beginning of an amazing cosmic spectacle? Betelgeuse is a giant star, about 764 times larger than our Sun. It is almost impossible for people to comprehend its enormous size. Mercury, Venus, Mars, and Earth would be swallowed by the giant star, and its surface would extend beyond the orbit of Mars. In addition to its physical characteristics, Betelgeuse is a red supergiant that will soon die. This stage is characterized by the expansion and cooling of the star's core, which is composed of hydrogen and helium fusion after its lifespan. How old is Betelgeuse? This star is believed to be ancient and relatively young for humans, with an age of 8 to 8.5 million years. It has evolved from a hot blue star to the red giant we see today in its current red supergiant phase, the culmination of millions of years of evolution. Nuclear fusion and gravity propel Betelgeuse through its life cycle of constant change. Another characteristic is that Betelgeuse has a characteristic red color during this phase. It is red because its surface temperature is lower than that of other stars like the Sun. Betelgeuse's cold surface temperature is about 3,500 Kelvin, while the Sun's surface temperature is about 5,500 Kelvin. But the color of this star tells us much more than how it looks. It also tells us about the state of its body and what is happening inside its vast gaseous space. Betelgeuse's historical color changes add to its mystery. According to ancient Chinese and Roman sources, Betelgeuse was yellow long ago. Arab scholars were quick to report that it was red, and only in the 10th century. The evolutionary history of the star is revealed by these color changes, which are also minor details in the past of astronomy. Betelgeuse's variable brightness is another fascinating feature. It is a semi-regular variable star, so its brightness changes frequently. Astronomers and sky watchers have been fascinated by this unique light dance for generations. Most commonly, Betelgeuse has two cycles, one lasting 400 days and the other lasting about 5 years. Aboriginal oral history may have included these cycles before, as discovered by Sir John Herschel in 1836. But what really makes Betelgeuse so mysterious is not just its variable brightness, but its irregularity. Betelgeuse occasionally deviates from its usual pattern of brightness and brightness, suggesting that unlike many stars, Betelgeuse's massive structure undergoes complex and poorly understood processes. In a recent groundbreaking discovery known as the Great Obscure, the appearance of Betelgeuse has changed dramatically and unexpectedly, capturing the attention of astronomers and scientists around the world. A prominent member of the constellation Orion and one of the brightest stars in the sky, the red supergiant Betelgeuse began to dim strangely in late 2019. The star's deterioration was so severe that its brightness began to decrease by an average of 0.01 magnitude per day, reaching its lowest level in February 2020. In areas with heavy light pollution, even casual observers could see the noticeable dimming of Betelgeuse, which is normally visible to the naked eye. The time paradox poses a problem when trying to monitor Betelgeuse's activity. Because light takes time to reach us, stars like Betelgeuse appear as they did in the past, not as they do now. In the case of Betelgeuse, the light we see today originated about 700 years ago when the star was about 725 light-years away. Because we are actually investigating the star's past, this time delay makes it difficult to predict and track sudden changes in its behavior. Betelgeuse's dimming event served as a reminder of the challenges of real-time astronomical observations and the limitations of our understanding when dealing with the vast scale of the universe and the temporal paradoxes it creates. The development of Betelgeuse's cosmic drama has been closely watched by Andrea Dupree, Associate Director of the Harvard-Smithsonian Center for Astrophysics, and her collaborators. They used Hubble to observe the giant star as part of a 3-year project to monitor changes in Betelgeuse's outer atmosphere. These observations provided new insights into the dynamics of Betelgeuse, a variable star whose brightness fluctuates as a result of periodic expansion and contraction. Hubble's ultraviolet sensitivity allowed the researchers to study a partially heated layer above the star's surface, which is partially heated by the star's chaotic convection cells. Further analysis of Hubble spectra taken at different times in 2019 and 2020 helped quantify the flow of material in Betelgeuse's outer atmosphere. The magnesium-2 line, which indicates the state of the star's atmosphere, was the focus of the spectra. Their calculations show that Betelgeuse's southern hemisphere has lost twice as much material as usual. Considering that, like all stars, Betelgeuse is losing mass regularly, albeit much faster than the Sun, this mass loss is significant. Astronomers have debated the magnitude of this mass ejection and whether the resulting dimming event signals a supernova explosion. The mystery is further complicated by Betelgeuse's proximity to Earth. The rare opportunity to view a supernova up close is provided by the explosion, which occurs 725 light-years away and is visible to Earthlings. But the question remains, what does Betelgeuse have planned for the near future? Is this dimming a sign of an impending supernova? Or is it just one event in the star's long and complex life? Many hypotheses have been put forward to explain this sudden change. Since it is widely believed that Betelgeuse is nearing its end, one popular explanation involves a phase of the supernova explosion process. Another common explanation is that our view is blocked by dust, perhaps by the star itself. Betelgeuse, like other red supergiants, is thought to have ejected material from the star, forming a dust cloud dense enough to block Earth's light. A third theory examines how changes in the star's photosphere, or visible surface layer, could affect the star's apparent brightness. In-depth research has been conducted to find an answer to this mystery. Spectroscopic results have shown that Betelgeuse's effective temperature has decreased, suggesting that a significant dark region on the star's surface may be causing the dimming. The fact that Betelgeuse's temperature dropped by at least 170 Kelvin during the dimming supports this idea, indicating significant surface changes. Humanity's cosmic watchdog, the Hubble Space Telescope, ultimately provided the key to understanding this unusual event. Hubble's measurements suggest that Betelgeuse's dimming is likely due to a large amount of hot material being ejected into space. Betelgeuse's ability to transmit light to us was diminished because this material created a dust cloud that covered part of the star's surface. The extremely hot plasma that forms the dust cloud is thought to originate in large convection cells on the star's surface and pass through the star's hot atmosphere to the cooler outer layers. About 25% of the star's surface was darkened by the cloud of dust particles that solidified as the star cooled. Since January 2019, Hubble's ultraviolet spectroscopic observations have pieced together a series of events that led to Betelgeuse's dimming. Several months before the star's dimming, these observations revealed evidence of hot, dense material flowing through the star's atmosphere. The star's brightness decreased in many ground-based telescopes in December 2019, especially in the southern hemisphere. As it cooled and spread outward, this material, initially brighter than the star's normal brightness, eventually formed a dark cloud. The sudden dimming of the star was thought to be caused by this outflow of material and the resulting dark cloud. The loss of some of Betelgeuse's surface due to this outburst may have been a sign of a core collapse supernova, where the star's core becomes unstable and collapses under the weight of its own gravity, exploding in a supernova. On a cosmic scale, such an event could happen in the not-too-distant future, or in 100,000 years, or even right now. The likelihood that Betelgeuse or other similar stars undergoing similar processes will explode increases with the Great Dark Singularity and mass ejection.